Hello, good day once again. In the last video, I've shown you how repetition is done in the analytical engine of Charles W. Babbage. I presented an nth factorial program with loop, which computes the nth factorial of any given number n using a repetition structure involving conditional cards called CF and CB, supported by the analytical engine. In this video, I'm going to show you a sample program that is used to demonstrate conditional branching. Typical of any program using any programming language are decisions that have to be made while the program is being run. Like for example, determination or computation of income tax, uh, translating of numeric grades into literal grades, and many others. In this example, I'm going to show you a program which computes the equivalent grade of a raw score as a result of a given test, using a typical formula for converting raw scores into grades. And we are going to find out whether the resulting grade is passing or failing. So typically, when you get or take a test, your test results will be converted into a grade using the formula score over items times quantity 100 minus base plus base. The most common base is 0, in which the passing score over 100 items is 75. The base value is used to adjust the passing score. The bigger the base, the smaller will be the passing score. For example, we are going to write a program in the analytical engine that will convert the score into its equivalent grade using 40 base. So we'll be using several variables. In this example, we are using variable 0 to record the base of computation. Variable 1 is used to store the actual raw score garnered, and the number of items is stored in variable 2. Variable 3 will store our resulting grade, and variable 4 will store the constant 100, which we use in computing the grade. Variable 5 stores a value of 1, which signifies passing. It is a Boolean value. Variable 6 signifies failing, so it stores 0, which stands for false. And then we will have a temporary variable in variable 7. The cutoff of 75, in this case, we are using it as 74.99, variable 8. The result, whether the grade is passing or not, will be stored in variable 9. So let us proceed with the trace. The first thing that the program will do is to do a divide, in which we are going to use an operation card. So we will divide the raw score by items. So the first operation card is a divide followed by L001. L001, remember, stores our raw score, which will transfer the value 60 to ingress 1. And L002 is our items. When we say L002, the value of variable 2 will be transferred to ingress 2, which is 100. And right away, the egress axis will store the quotient, in this case being 0.6. And then we will store the partial grade, which is 0.6, to variable 3. So we will have the command S003 or store 003 with a prime. Remember, we are doing division here. So when we do a store, we use a prime because the quotient is stored in the prime egress axis, not in the actual egress axis. The next thing to do is to subtract the base from the constant 100. So we are going to do a subtraction involving variable 4, which is the constant 100. So we have L004 followed by L00, which is our base of 40. So subtracting 40 from 100, we will have a value of 60, which will be the value of the egress axis. Take note that this is a deduction or a subtraction, which will affect the run-up lever. But the run-up lever in this case will remain 0 because the result is not negative. We will store the difference between 100 and the base into our temporary variable 7. So we'll say S007. So the value 60 will be stored in variable 7. Then finally, we are going to multiply, do the last multiplication, multiply the result of 100 minus base to score over items. So the next card is a multiplication card involving L003. Remember, it's 0.6, our partial grade. And L0007, which is the temporary variable, in this case is 60. So, 0.6 times 60, we will multiply that, which will give you 36. And we will store it to our temporary variable, which is L003. So 36 is in L003. The last thing to do to compute the grade is to add the base. So we are going to have a plus operation card involving L00, which is the base, and L003, which is our partial grade of 36. So we know that the actual grade in this case is 76. Now, we will store this result to our variable 3 again by using the command S003 76. The next thing to do is to evaluate whether this is a passing or failing grade. Now we will do a technique called an if then else in a programming language. However, we have a problem because the analytical engine does not support an else operation. We have an if operation, but the else operation is not supported. This is a very popular question. How do you do an else if an else is not supported? Let me show you a sample C program that is almost an equivalent of this part and demonstrate how to program an else if the language doesn't support an else. For example, we have the condition if G is greater than 74.99, we say R equals 1, which means if the grade is greater than 74.99, the grade is passing. Else R equals 0, which means that if it's lesser than or equal to 74.99, it is failing. We mark it as 0. Now, if you don't have an else, the popular technique to do this kind of a logic is to do the else first. Remember this, if you do not have an else, you can do a branching by doing the else first. So in this case, we say first R equals 0, or we assume it's a failing grade, and then followed by the normal if. If G is greater than 74.99, then we will say R equals 1. It's just the normal process. I'm showing you this because this is the logic that we are going to follow in our analytical engine program, with the else statement being unsupported. So the first thing to do is we will assume that the program is failing. To be able to get a 0, which stands for failing, we'll just multiply a number with any number with 0. In this case, our failing variable, which is in variable 6, which can be used to compute a value 0. We will multiply the variable 6 with any number, shall we say L005, which is 1 in this case. It doesn't matter what you multiply anyway, anything multiplied with 0 becomes 0. So the egress axis becomes 0. And we will store the result to S009 as 0. Now, we are doing the else branch already. Then we proceed with the if. The if statement in the analytical engine is done using a subtraction. For example, we will subtract our result with the cutoff. And if the result is negative, then uh, the grade is passing. So in this case, we will do an L008, which is our cutoff. L008 is 74.99, and the resultant grade is 76. We will use a negative or a subtraction operation card. So in this case, we compute 74.99 minus 76. which gives us -1. With the result as negative and the first input as positive, the run-up level of the analytical engine will be set to 1. Otherwise, it will be set to 0 or reset. Now we follow with a combinational card. CF question mark 3. CF means count forward only if the run-up lever is 1. How many times do we jump? 3 times. Now, since the run-up lever is 1, in this case, we will skip the next 3 lines, 1, 2, 3. After which, we are going to correct our previous declaration of 0 to 1 because this is a passing grade. So, we will multiply numbers with 1. In this case, we do a multiplication card involving L005 and itself, which means 1 times 1 equals 1. And we will store it to the variable 9 as 1. And then we will do a halt, particularly involving PBH, print, bell, and halt. And we have declared that the grade of 76 is a passing grade. Okay. Now, let us trace this back again involving a failing grade. Will this work? Will the sequence work? Let us try. Let us try the score of 45. So we will change the second line from N00140, 60 rather, to N00145 because 45 is obviously a failing grade in base 40. So we will proceed with dividing L001, which is 45, with L002, which is 100. So instead of 0.6, we will have 4.45. 0.45, and we will store it to the variable 003 involving the prime egress axis. And then we will subtract the value 100 with the base. So L004, which is our 100 constant, and L00, which is our base, which is 40. We will subtract that. We will have a value of 60. And we will store it temporarily to the variable 7. And then after that, we are going to multiply it with score over items. The score over items is, as we have computed, is 45. We will proceed with a multiplication card involving L003, which is 0.45, and L007, which is 60. In which case, 0.45 times 60, the egress axis will be 27. This is a partial grade, so we will store it to variable 3 involving S003. So this will be 27. The last part is to add it to the base. So we will use an operation card plus L00, which is our base of 40, and our partial grade in variable 3, which is 27. So the result is 67. And we will store it to our grade variable, which is 003. So the value is 67. Now we will proceed again to determining whether 67 is passing or failing. First, we will uh, we will proceed with the else part, which means that we will assume that this is a failing grade by marking the result as 0. So to force the computation to result to a 0, we multiply any number with 0. So we have number 0 in variable 6, so we say times L006, which is failing, and times L005 or L006, in this case, which is 1. So anyway, 0 times 1 is a 1. 0 times 1, I'm sorry, is a 0. And we store the result 0 to the variable 9, which is our result. In this case, we were assuming that this is a failing grade. And then we will do an if. Likewise, an if is done using a subtract or a deduction. So we use a subtraction card involving L008, which is our cutoff of 74.99, and our resulting grade, which is 67. So if we will deduct 67 from 74.99, we have 7.99, which is positive. In which case, the run-up lever will be 0. So if we say CF question mark 3, CF stands for skip 3 times only if the run-up lever is 1. Since the run-up lever is 0, it will not skip but proceed to the next line, which is a print, proceed normally to the next, which is a bell, and finally to a halt, which means that our previous assumption that 67 is a failing grade is correct. So this illustrates that decisions can be made in the analytical engine. You can now start doing your assignment on the Fahrenheit to centigrade conversion, in which you are going to determine whether a certain temperature is within the fever range or not. In the next video, I'm going to show you the structure of the next important computer in the history of computing, which is the IAS. See you then, and thank you.